Okay, we can get started. So this is Python for analytics. We'll be mainly focusing on the Pandas library. Yes. Yes. Thank you. We'll be mainly focusing on the Pandas library, hence the panda photo. There's going to be a lot of those. Yeah, so we can get started. So unfortunately, we're not going to talk about the animal today, although it would be a much more interesting presentation if we were. But what is pandas? Although a panda is very cute and fluffy, unfortunately, once again, we're not going to talk about those. For our purposes, though, as data analytics interested individuals, Pandas is a package in Python. It's kind of heralded as like one of the gold standards for data analytics. A few others like NumPy we're not going to be talking about. Personally, I think Pandas is kind of the best, like the go-to in Python. Kind of why is that? Standard Python isn't super friendly to data tables. They have them and you can work inside of them, but to get the most functionality out of it, importing it into a Pandas data frame is kind of going to be your go-to for just about every problem. There's a lot of functionality for just reading in data. I think they recently added something so you can read in like SLSX files from Excel, which I don't think you can do without Pandas. There might be some other, but essentially, Pandas takes a simple collection of data that you would see in like a standard Python format, and it just pretties it up. It adds a lot of metadata behind it. It adds a lot of moving around functionality. Well, it's nice. It also will add, it'll take, there's a lot of ways that you can modify how it reads in. So you can modify the certain like UTF code that it reads it in. You can also change what initial values it reads as the columns. So some data will read in with these column values up here, others won't. You can move that around and modify it. But mainly we use this because it makes it much more simple to work with and manipulate data frames that you'll see all the time. It allows us to do things like this, where we can take very dirty data, which this isn't super intuitive to look at regardless, but a lot of data you might see makes sense when you're writing it to an Excel file, but then when you want to work on it at scale, it falls apart very quickly. And so this will allow us to do something like this, where we were to take this very jumbled data, move it around a little bit and make it nice and clean, allowing us to do more things down the road. It also allows us to do things like this. Just about anything you can think of in terms of data manipulation or statistics can be done in Pandas. Once you kind of get the basics of it, it's very intuitive where to go from there. If you just have a question or a curiosity, you just Google like Pandas, find the sum of a column, and Google will give you some way of doing that. We'll go over a bunch of these in the code later, so you don't have to worry about it too much right now. But yeah, so we're just the way today's gonna work, if y'all wanna write in this Colab file, this short one should work. If it doesn't, let me know. We're gonna go through how to manipulate and work with data frames, and then I'm just gonna work through some data. I couldn't find a data set on like Pandas the animal, but we're gonna be working with penguins instead, which might also be interesting. So yeah, I'll give you all like a minute to type that link in. You don't have to follow along. I'll be going through it. But I'm kind of just going to be describing how each one works, what you can do with it. And then at the end, I'll give you a second to kind of experiment with some of these that we'll be talking about. Okay, so first things first, Pandas is a package in Python. All packages need to be imported. Using Colab is really nice because they all come installed by default. If you want to follow along not in Colab, you'd have to use some sort of like pip installer to install Pandas. Seaboard is only in here for the data sets. It also can do cool visualization stuff if you're curious, but we're using it for the data sets. So if we just click this, we run it, it's not showing anything, but now we can use this PD symbol. And if we do a dot afterwards, where we have access to just about everything Pandas can do. Same with Seaborn. So as we can see here, we take just this identifier that we labeled to Pandas, or we labeled this one to Seaborn, put a dot after it. And then if you like give it a second, it'll pull up all the functions and abilities it has, and you can kind of scroll through them. And it's a good way to learn about new ones, read through them. If you think something can do something and you just put a dot after the identifier, you can kind of look to see something that might have the word you're looking for. For example, if I wanted to do a histogram or a histogram plot and I didn't know necessarily how to type that in, I could just do .hs or .hi and it'll pull up that histogram plot. But for this one, we're going to be using data set names just to kind of get a list of all the imported data sets. I picked taxis. Some of these are really weird. Brain networks is interesting, but it doesn't really make sense to me. So we're doing taxis instead for now. We'll go to penguins later. And so same idea. We do this SNS dot, and then we want to load in this data set that we found. We run it, and we get this. So if we were to try to load in data not using pandas, we would get something similar to what we saw up here. It's really small, but it wouldn't look this way. And you can kind of, you might be able to see that. It would look sort of something like this. Not exactly, but the same idea where the data is all here, but it's not put together very well. It's not as easy to look at, and you can't really modify it as well. And so instead, we load it in pandas, and we get this nice and neat data frame. Dot head is just a function that takes the first x of a data frame, and we can change that. So we could do dot head 15, and it would return the first 15 values. It's just a nice way to quickly look at data. But so we can see that this taxi data set contains pickup, drop off, passengers, all the various information you might want to know about doing analytics on taxi rides. Or we can also see, it'll be down below, but we can also see if we were to do taxi dot shape, we can see there's a gamble whether there's a parentheses or not afterwards. We can see how large the data set is. So this one has 6,433 rows and 14 columns. We can see the 14 columns here, but because we did head, we don't see all the rows. There's quite a few rows. We can also do dot describe. And this will give us a little bit more information about our data set. It's a little harder to read though, but it still has at the bottom, this not rows by columns, but it also gives us some various information about just more data to look at. So if we want to start, first thing we do when we load in a data set, you can just call heads, but potentially there might be a lot more than 14 columns. Your data could have hundreds of columns. And so what we want to do is just look at these columns in this data set. We don't have to have list in front of it. If we run it without list, it doesn't look as readable though. And so calling it to list just takes everything down here and makes it easier to look at. And so we can see all the same columns that we had above. This is a good way if you just want to get quick information about the columns in the data set, but also down the line, we're going to be using these column names to manipulate our data. And it's not always super intuitive how to write that in. I don't have a good example about that, but sometimes you read in data, like in this example, this data up here is technically going to be read in as a column, but there's no information there. And so it'll read it in and it'll give it a value, but when you're looking at it, it's not super intuitive how you would call that column. And so, using taxi.column or whatever data frame.columns will give you the names, so that way you can then manipulate them. So say we want to take this data frame and we want to just look at one column. So in pandas, this whole thing, it's called a data frame, but one specific column is called a series. So if you were to manipulate this in a certain way, it might sometimes return a series. So it's kind of good to know if you see the word series, what that means. It's essentially just a list of data, but it's only one column worth of data. And so if we want to just grab one column to look at that, the easiest way to do that, there's a bunch of other ways, but the easiest way for me is just to take the name, the data frame name taxis, use these brackets and put the name inside of it. And so we can call this, we can see taxi passengers. We could also look at something else. This brackets just essentially tells Python that we want to not call a function on our data frame, but look inside of it and grab something out. And so having parentheses around it would just indicate something different. But when we call this, it'll load up all of the different column names. So it's another way to kind of grab one really quickly. And so we could look at this instead. And so now here it shows the index of all these values as well as what they hold, like what value they hold. So Pandas also comes with a large variety of functions to help us do basic statistics on these columns. Really just about anything you can think of. If you just type it in, it should work. If it doesn't work, you just Google how to do it and somebody else will tell you. The great thing about using Pandas is that it's used by a very large amount of people. And so more often than not, if you have a question, it's already been asked before and it's already been answered, as well as somebody has gone through. And if they couldn't answer it right out of the gate, they've created something and added it to Pandas to make it so that we can do what we want to do. And so, for example, if we want to take the average number of taxi passengers in this entire data set, we just call it. This just prints it out nicely. And so we see that on average, throughout the entire data set, we see about 1.5 passengers per visit or per ride, which makes sense. There'll be some variables in there that'll kind of skew it, but most people travel with one or another person. And so we can just print out the rest of these and I'll walk through them. So the same idea, standard deviation, maximum just looks at the largest value in that list, same with minimum. It's kind of just showing the point that these are all very basic things that you'll learn about in statistics, and you can do them pretty simply in here. Now, value counts shows the number of unique pickups at each location. There's other ways of doing this. For example, I'm pretty sure you can call it just dot unique at the end of it, and then you could loop through every single column name and call it dot unique, and just it'll print out the number of new unique values. Well, dot unique will print out all the unique values, but then if you just find the length of that, it's number. But value counts is just a simple way of doing it. So we can see that the number of pickups at each unique location is 5,000 at Manhattan, 600 in Queens, 300 in Brooklyn, and a little less than 100 in the Bronx. Is there any questions so far about kind of what we've done? Yes. Most Python, typically the way you're using Python will be through like a package management system. And if you just do like pip install Python or like conda install Python, it should already be in there, or pandas. Yeah. Yes. Yeah. So this is just like a formatted print statement. And so we called this, and then in here we just this percent symbol essentially just tells the system when it's reading this that we're going into like a special character that deviates from typically what it would be. And so this tells it that what we're grabbing is a float value, which is just a number. And then this tells it that the next value is that float. There's other ways of doing this. If we were to put like an S here, it would tell it's a string and it would look for the next string and print that. If you're ever curious which ones, you can just type like Python like formatted print and it'll just list out all the various print values. And so the way all these work is we grab this taxi data frame, we get the specific column we want by calling the name of it. And then once we have that value, we pass it into mean and it outputs the number. So moving on, we can also grab rows of data, not just columns of data. And so we can do that by kind of a confusing way, but a way of doing it just to grab a specific row is .iloc, which stands for index location, and it grabs the 0 row of data. And so if we call it, we just get the first row of data, which should be the first row of data we saw here. And we could change that to just about any number as long as it's less than the number of rows in our data frame. iLock has other purposes. So if you're curious, you can kind of search it up. You can use it for other ways, not just grabbing rows of data. We could also grab multiple rows of data if we were to do like, I think 0, 2. We can grab the first 2 rows of data. And so we could do, once again, the same idea all the way up to n, the number of rows in the whole data frame. A more intuitive way of going about it is just .loc, which is just grabbing the location by a certain value instead of a certain index. And so we do this by, and so this works by finding some like conditional value inside of this and like applying it to every row in the data frame and then returning whatever ones satisfy that value. And so just to kind of break it apart piece by piece, we have this taxi data frame. This calls the, this grabs the column with all the passengers in, so grabs that column from that data frame and then returns, if we just return this, it returns a true and false. So whenever a trip has more passengers than 1, it returns true. And whenever it's 1 or less, it's false. And so then we then take all these true and falses and we do this .loc, grabbing the location by this true and false value, and it returns every row where this value is true. This can get very complicated very quickly. So if I'm kind of going ahead of myself, just ask a question, it's very fine. And so we see here that these first 4 rows will not be returned because their value is false. And so if we run this whole thing, we can see that the first index of the row is 4. And so 0, 1, 2, and 3 were skipped. Are there any questions kind of how that works? Okay. So we can kind of expand this as far as we want using Boolean statements. And so this is the same idea as above, but instead we're not just grabbing this one condition, we're also grabbing this other condition. And so if we were to just run this whole thing, it would return a bunch of falses because most trips, because the Bronx only had 99 trips, a majority of them probably aren't passengers greater than 1, or yeah. And so it's gonna be false for most of these values. And if we run this, we can see that our first value is 1848 and our last value of the 5 is 5,735. And so, but this just kind of shows how you can string together multiple conditions. You could also use or statements, not just and statements. And this is a good way to very succinctly filter your data to what exactly you want. And so we could change these to other things. We could change these columns to something else. We can use just about any, we can use like less than, greater than, less than or equal to. If you're curious kind of what type of data this is, it's kind of intuitive off like just by looking at it. But for example, we don't necessarily know if this pickup is a string or a date. I think it's like dot type. If we just run this, there is a way to do it where you can just return kind of the type of that specific column. If you're curious, I mean, just Googling it would return the answer. But then once you know the type, you kind of know what value to pass to it to do your conditional. If you're ever running this and you get nothing back, a good chance is probably that you put in the wrong type. Like we put this as like a 1, we'll either get an error or it'll return no values. Python's pretty good at letting you know when you've done something wrong. So so we can still subset specific columns even when we do this .loc, and so we don't always have to return this whole data set. We can grab all the values where the passengers are 3, as we did here, and we'll get this whole data frame, but we don't always want this whole data frame. And so we can use the same logic we used before because this returns a data frame. So this value, or this statement returns a data frame, and we can still filter that data frame the same way we would filter a normal data frame by just putting this these brackets on the end with something inside of it. And so this will return what we had, but only that one column. And we can do the same idea with the .iloc and just return the same, just the first column of that data frame. And so whenever you do something that's applying itself to a data frame and returning a data frame, we can expand on that and do it again because it's returning a data frame. Are there any questions on how that works? Okay. And the same idea as we had up here, where we were taking a specific column of a data frame and doing functions on it to try to return statistics. We can do that with what we just did. And so we can return a filtered data frame, as we see here. So this will take all the taxi rides, the tolls that they passed were more than one, and then we return the fares of that data frame, and then we can take the mean of that. And so very simply walking through it, this takes that data frame, returns only the tolls column. So it, like a toll is whenever you go through and you have to pay money to drive on that road. And then it returns the number of tolls they went through on that trip. And so if it's more than one, it returns what's trues. If it's one or less, it returns falses. And then it uses the same condition logic to return a data frame where the tolls are exclusively greater than one. And then going forward again, we take that data frame and only look at the fares column. And so just returning that would just return a bunch of fares where the tolls are greater than one. And then because this returns a series of numbers, we can do statistics on those numbers. And this whole thing will return just a number, which is the mean for those toll rides. And so we run both of these. We see that the average fare for rides with tolls involved was about $30 per ride, higher than when no tolls were involved. And so this is the sort of thing you might be asked to do at like an internship. It'll probably be a bit more in depth than this, but it'll just be a question that they have, they're curious about, and knowing how to manipulate, move around data so that way you can find the answer to those questions will hopefully impress them. It's hard to say, but it's just a very simple kind of going through what we've done to answer a question that somebody might have. If you want to grab just a single value of a single cell, we can use the same idea we did before to grab a single row and then grab a single column from that row, and that'll just return a value. So if you need to specifically know one cell's worth of value, and this can be helpful if you're trying to find a very specific case, but you don't necessarily know where it is in the data. So if you're doing something and returning an error because something is like a null value, you can use the same conditions that we did up above to find where that null value is and then return the column that it's holding, or return the value in a certain column and get that specific data point. Just potentially when you would need to use this. Are there any questions of what we've done so far? For the last probably 15, 20 minutes, we're just going to look through this penguins data set and just kind of showcase a bunch of pandas functions. Once you kind of understand the basics of how to move around these data frames, most of pandas is pretty intuitive, just in terms of if you have an idea and want to do it, there's a good chance you can do it. So I think just getting a lot of exposure to various like pandas functions can be helpful. So we can do the same idea before. And this time I just picked out this penguins data set. And if we load it and look at all of this data, we can see that this data set returns species of penguins on an island, and then some flipper and bill statistics, as well as their gender. And then .info is how you would see the data type of all these columns. And so object is just a string, and float 64 is a number, as we can see up here. And so if you're curious whether something is like a date or a string, this would be a way of getting to that information. And then we can see that this has 344 rows and 7 columns. So first we might want to do some cleaning of this data. And so this is a pretty complicated, it's pretty complicated here, but it's just so it's pretty looking. But essentially we just look at each column in these columns. So if we return just this, we're just getting a list of the columns. And then this essentially grabs each column in this list and runs through this loop. And so once we have this column value, we go through the loop once, and it says if the penguins of that column is NA, so if there's a null value or not applicable value because it read it in wrong or because there was no data for that value, and the sum of all of those NAs. So essentially this will, if I, so if we were to run this, this would essentially just return a bunch of true and falses where something is true if it is NA. So if we look back up here, this third one is a null value. And so it returns true for that. And then if we were to take the sum of all of those, it's just going to return the sum of all the true values, which is 11. And so if it's 11, then we would print out the number of null values in that column as a percentage of the total data. And so we run this and we get 2 null records for each of these. And so this could be just a good way to see how complete your data set is. And so we see here that most of these aren't too bad. The gender has a lot of null records. Does anyone guess as to why? But we can drop that column because if we were to do like machine learning with this data set, it's not always great to have NAs because it doesn't always know what to do with it. There are other ways you can replace it with just the average value, but just for simplicity, because there's not too many, we're just going to drop it. And so this works by just selecting the data set where the values are not NA and then returning that into the original data set. And so you could also drop, use like dot drop, and it'll drop all of these, but it's a bit more readable. And so we just run this, and now if we were to run this again, nothing prints because none of them have NAs. And if we were to look at this again, we can also see that we now only have 333 entries instead of, I think it was like 344 because we dropped 11 values. We could also change the type of a column. So if one of these read in wrong, like if flipper length read in as a string and we want it to be a number, we can change it back to a number. And so for example, if we were to run this, we just changed penguins, this column build depth to type string. And if we were to run this again, if you look for build depth here, it'll change to object. So now it's an object. And we're going to change it back just because we don't want it to be that. And this just does the opposite, changes it back to a number. Are there any questions on how data cleaning is a very deep subject, but it's just kind of showing how Pandas has steps for just about everything along the way that you would need it to have steps for. Okay. We could also grab some quick summary statistics on our data. And so if we want to find the uniqueness of each column, this runs the same way. It assigns one of the columns into this variable and then prints it out nice and pretty, where it essentially just grabs the length of the unique values. And so once again, if we were to just run this, it's just going to output the unique values in that gender column. And then the length of it is the number of unique values, which can help you to determine what you want to do with that data. So like for this, they're returned as strings, but for machine learning purposes, it might be better to have them as factors because it's more readable as data when they're factors because they're assigned to numbers. And so knowing the uniqueness of columns isn't just for curiosity's sake, but it can also help to improve model performance or improve like the statistics you want to look for. And so we can see here, species has 3 unique values, so does island, while bill length, depth, and all of our numbers have much more, which makes sense. But we might want to then change these to factors if we were going to do machine learning on this data, and we wouldn't want to change these because they're numbers. And we could also do describe, which just outputs a bunch of simple summary statistics for our data. all the ones that we did above would still apply down here. So if we wanted to specifically take the mean of one column, we could also do this. But this is a pretty simple way of looking at it all. And then, so given what we've kind of learned, let's try to describe some potential proposed questions using pandas. And so you're obviously not going to be asked to do this specifically, but you might be asked to do something along these lines where it's a very off the top of their head question. It's not super explicit on how you should do it, but it's just something they're curious about, and you have the data. And so you would just have to then go through and answer that question. And so we want to find out which island has the fattest penguin, because everyone wants to know that. And so there's two ways. There's a very large number of ways of doing this, but one way we could do it is by doing the same idea we had before, by printing each island and the statistics associated with it. And so we take this like condition of penguins on an island, and then we return a data set for that island, take the body mass of that island, and return the maximum value from that. And so once again, kind of walking through it, this first one will just return something where we would have to assign this isle to a specific island. We kind of get the idea. It'll just return a data frame where all the islands are specifically like Adelie or Chinstrap. It's an interesting name. And then once we take the body mass of that specific one, we'll get all of these values. And then we can take the maximum from that and print it out. So if we just run this first one, we can see that Pisco has the fattest penguin of 6,300 grams. I don't know how that converts. It's pretty considerable like improvement in terms of penguin eating competitions, over 4,700. And so you got to imagine those penguins doing pretty well, living their best life. And another way of going about it, just to kind of showcase how pandas is very fluid and can do problems in a very large variety of ways, we can also instead group by islands. And so this group by works by taking all of these, it returns an object, which isn't very well. So it just sorts all of these into specific columns. And so we can see here that the third column got removed because we removed it ourselves. But it got removed for some reason. And so it just groups all of the columns into their specific islands. So that way we can do statistics on them in a very neat way. It's the same way that if you write in SQL in any way, you can do the same idea to find statistics on each grouping of data without having to write multiple queries. But we can run this and it'll just return the maximum. It'll return. Okay, there we go. So it returns an island, so we know what we grouped by, and then each specific island and a specific value. It's just kind of another way of doing the same idea. Whatever one is more readable or easy is really up to you. So another question would be, which species has the smallest bill length to depth ratio? That would be short and stout, I think. And so I'm gonna leave that up to you. I'll give you like 5 minutes and then we can go about and do it ourselves, and I can kind of walk through how I would do it. If you have any questions, just like raise your hand and I can answer them. This bill length over bill depth is the ratio we're looking for. So I guess just a little hint. In the same way that you can like kind of modify data frames, like returned data frames, you can also do math on those returned data frames. And so in theory, we could always divide a column by another column. So I'll give you a few minutes to try to write that out. Does anybody really want more time, or otherwise I'm going to go through it? Okay, so I'll kind of walk through just intuitively like how I might think about approaching this. I do have the answer somewhere though, but I should be able to figure it out. So if we do just penguins, because we want to grab that data set. And then we know that we want to take the ratio of these two columns. And so if we were to just grab those two columns out of the bat, we could run this and then we would just have these two columns. And so just to kind of show you, this would just return that column's worth of data the same way we had above. And the ratio we want to go for is length over depth. And so we can divide these two columns and we'll return some value of these two columns divided by each other. And so that's kind of what we're looking for. And so we want to then find the smallest one of this for each column or for each island. And so just grabbing a specific island, or we want to go each species. So if we also were to grab this and then return it, we would get all the unique species. And so we see the species we want to look for. And so just to expand it one amount, which is kind of a good way to go about it. You want to get like a base case of how you would go about doing it and then expand it in levels of complexity. Because if you start out just trying to attack it all at once, you might get a little confused. Or you might reach a point where you think it works, but it's missing something and you don't really understand what it's missing. And so if we take just one of these values, we want to and then we just copy and paste in front of the other one. This will return the same idea, but on this specific species of penguins. And so now that we have this value, we could also put some parentheses around it and take the minimum value of that return. And so this will find us the smallest value in that specific species of penguins of this ratio that we're looking for. And so we could loop through all of these different species and get the unique values, or we kind of do the same idea we had up here to loop through it for us so we don't have to ourselves. And if we just change some things around, so if we just change island to species, bill length to bill depth, and then we just copy this value, put it on top of itself, and put a little divide symbol in between, changing this from length to depth. Python doesn't always understand what you're trying to do. So now we have this, and if we were to run just exclusively this, it's the same idea we had up above. It just shortens it all into one line and runs it through a loop, so we don't have to run it through this loop ourselves. Oh. Ah. I had the same issue before. Anyone find? Oh. We don't want to divide too early. It's my bad. Dividing too early would try its best to divide this value by this. And so try to divide a column or try to take a column and put underneath it an entire data frame, which might try its best, but it's probably not going to work out the way we want it to. And so we want to wrap these in parentheses. So we're returning this instead of this, because that won't divide very well. And so now if we were to run this whole thing, it'll output the values we want. And we can see that the Adelie species of penguins has this shortest bill length to bill depth ratio. Oh, struggle. Are there any questions kind of how I got there? Are there any questions in general? Doesn't have to be just about pandas. If there are no questions, I can put this back up. You can sign in if you missed your chance. But that's all I have for today. You have the last like 7 minutes back. I don't know if there's more pizza, but if there is, you're free to take it. If there isn't, thank you for signing up. Thank you for showing up. And hopefully, thank you for signing in.